All right, picture this, a high-stakes crime scene. But there are no fingerprints, no physical evidence at all. Just this silent digital breach. The intruder is a total ghost in the machine. Well, this is the world of network forensics. And today, we're going to be the detectives.
I mean, it's a pretty paralyzing thought, right? A company's entire digital lifeblood is compromised. The attacker could be literally anywhere, and that trail is going cold by the second. This is the exact question that keeps security experts tossing and turning at night. So how in the world do they start to unravel this kind of mystery?
Well, they start with the science of digital detective work. It's called network forensics. You can think of it as the super meticulous capture, recording, and analysis of all network events. We're talking about the digital breadcrumbs left behind, all to discover the source of an attack. It's basically how investigators take total chaos and turn it into a story that actually makes sense.
Okay, so to really get this, we've got to shift our perspective a little. A compromised network, it's not just some technical problem. No, it's an active crime scene, and it is rich with clues, just waiting for a trained eye to find them. You see, every single interaction that happens on a network leaves a trace. I'm talking about a login attempt, a file transfer, heck, even a simple ping. For a forensic investigator, these are not just random bits of data. Oh no, they are the potential footprints, the stray fibers, the partial fingerprints that the intruder left behind. So, where do our digital detectives even start looking for their first clues? Well, they start with the absolute fundamentals, the building blocks of all network communication. Just think of these as the digital version of DNA and fingerprints.
And this is where it gets really cool. This model right here, the OSI model, it shows us the hidden order in all that chaos. See, network traffic isn't just one giant messy jumble. It's actually organized into these distinct layers, kind of like an onion. An investigator can literally peel back these layers to see, okay, did this attack happen at the physical level with a rogue device, or was it up at the application level through a software bug? This structure is absolutely key to pinpointing the exact method of attack. And check this out. This is a great way to think about how data actually moves. On one hand, you've got TCP. Think of it like a registered letter. It's super reliable. You get that delivery confirmation. Then you've got UDP, which is more like a postcard. It's fast, it's simple, but there are zero guarantees it'll get there. Now, this choice is a huge clue. An attacker, for instance, might use that fast and loose UDP for a denial-of-service attack to just overwhelm a server, but then switch to the more stable TCP to carefully, quietly pull out sensitive data.
And here's the bottom line. Attackers can try to cover their tracks all they want, but the raw data itself, it tells a story. As the forensics expert Laura Chappell famously said, packets don't lie. They are the ultimate source of truth, but they aren't the only source of truth.
So beyond those raw data packets, our investigators have another, really powerful source of evidence. You see, on pretty much every device, there are digital records of everything that happened. Let's call them the unseen witnesses.
Think about it. Every server, every router, every firewall on a network is constantly just taking notes. They're creating logs of every single significant action. A failed login, a new connection, a change in the settings, it is all recorded. For an investigator, these logs are like a room full of silent witnesses, and each one is ready to tell their part of the story and help build a perfect timeline of the attack. But wait, you might be thinking, with literally millions of events, how do you find the important clues? Well, you prioritize. See, logs are assigned these severity levels. So instead of wading through a sea of minor debug messages, investigators can jump straight to the top of the list. We're talking emergency, alert, and critical events. This whole system lets them instantly filter out all the noise and focus on what are essentially digital screams for help. Now, of course, these digital detectives don't just rely on their intuition. They have a seriously powerful toolkit of specialized software, all designed to capture, dissect, and analyze all of this evidence. Okay, so first up, you've got the investigator's digital magnifying glass. A tool like Wireshark is what's called a packet sniffer, and it basically captures network traffic in real time. It lets an analyst zoom right in on individual data packets and examine their contents piece by piece, just looking for anything suspicious or out of place. Yeah, it is painstaking, super detailed work.
You know, the threat isn't always coming from the outside either. Sometimes, an attacker actually plants a rogue device inside the network, and that's where a tool like VStumbler comes in. The best way to think of it is as a digital bug sweeper. It scans the airwaves to identify all the Wi-Fi networks and devices in range.
helping investigators spot some unauthorized access point that could be secretly siphoning off data.
All right, so we've got the packets, we've got the logs, and we have the tools. So, how does it all come together to finally crack the case and tell the full story of what really happened?
The answer is something called a SIEM. That stands for Security Information and Event Management. Just think of it as the central command center for the whole investigation. It pulls in log data from thousands of different sources, we're talking firewalls, servers, laptops, you name it, and puts it all in one place. And that's what allows an investigator to finally see the big picture.
And this is what that big picture looks like. A platform like Splunk, it acts like the master evidence board in a detective's office. It takes those millions of individual log entries and it just starts connecting the dots. It correlates events across time and across different systems, and it reveals patterns that would be completely impossible for a human to spot. You know, a failed login over here, followed by a strange file access over there. And suddenly, the attacker's path through the network becomes crystal clear.
Because ultimately, the goal of all this hard work is to build a final report that answers those classic, crucial questions. Who was the attacker? What did they do? When did it happen? Where did they come from? And, maybe most importantly, why and how did they succeed? This complete narrative, that's the final product of the whole investigation.
But, and this is a really critical takeaway, finding a compromised machine is not the same thing as identifying the actual person behind the keyboard. The network evidence gives you the path, it gives you the how, but attribution, that's proving who is actually responsible, that is often the hardest part of the entire puzzle.
So, at the end of the day, network forensics is our best tool for shining a light into the dark corners of a digital intrusion. It lets us reconstruct exactly what happened and understand our own vulnerabilities. But you gotta remember, it's a constant cat-and-mouse game. As attackers get smarter and devise new ways to hide their tracks, the detectives have to continually innovate just to keep that light shining brightly. And the big question is, can they keep up?